Hi buddy, thanks for speaking to me. What's your name, sorry sir?
Adam.
Adam, I'm Dale Adam.
How you doing?
I'm just asking students some general questions and a couple of topics to see what they've heard of this stuff and what they actually know. Can I ask you first and foremost what it is you're studying?
Computer science.
Computer science. Can I ask you, have you ever heard of Alexander Euclid?
No.
You ever heard of Euclid's elements?
No.
You ever heard of Euclidean geometry?
No.
You've never heard of that? See, I find that really incredible that students and universities have never heard of this guy. He's known as the father of geometry.
Right.
You know, he put it into mathematical papers and stuff like that. Around about 1600 years ago. But what he put in the papers was being used previous to that. Okay. And it's basically a mathematical axiom, the base for what, you know, practical applications are used, like construction, navigation and stuff like that. So it's called Euclidean plane geometry. Okay. And it's applied in everyday reality. So we have plumb and level. You know what plumb and level is? You understand that's the principles of construction. Yep. And we use it across the whole board. It doesn't matter who you are, you're an engineer, an architect, whatever, it's all used, these principles. So what it is, mate, I'll just get to the crux of this whole thing, right? What this is in regards to is the shape of the world. Okay. Have you heard people questioning this? Yes. What's your thoughts on that?
Unless there's proven information to say that it is flat or isn't flat, it's round until somebody tells you otherwise.
Could I ask you your reason processes behind why you would go with that?
Because that's what we were brought up with, that's what we were taught. The first picture of a globe is a round globe. The first globe that you get at school is round, like that's just what you're taught. Excellent,
that's exactly what I'm looking for, is that honest response. Can I ask you then, what was your perception of what science actually is? What would that be?
In the grand scheme of things, different numbers, different letters, different mixing different chemicals to create something, like it's...
So if I says this to you, then it's about the world we live in, and it's about substance and objects and dimensions and quantifying things.
Everything that you can hear, everything you can feel is something to do with science.
Do you think that aspect where you were saying is just seeing? Seeing's not enough for me. No. You have to be able to move three-dimensionally around objects to be able to quantify them and so forth. So the problem that I've found is, and I like your honest response because that's usually the response, the Earth has been measured, and what I say to you about Euclidean principles, that's plane geometry. Right. So if we're applying, you can't apply plane principles to a sphere. Okay. But the confusion is coming in, as far as I'm concerned, with people is because of this image, as you stated, that you see on a TV screen. Right. So would you then, you know, to say that it's scientific to believe an image you see on the TV over measured reality? Would you accept measured reality, or would you accept an image? I would accept results. I wouldn't look at a TV screen to fit a picture. I would use my measurements to fit a picture. Exactly, so spot on. I would want the measurements to then tell me that this is a round board, this is a square board, whatever. So would it concern you then that this image that you're showing you has never been scientifically measured or proven in any way, shape or form? It would surprise me, but it wouldn't concern me. Wouldn't it concern you? Do you not think it's important to know exactly where we are? It's important if it's going to make a difference to our lives. Like, I'm not going to pass my exams because the world is square or triangle or flat or whatever, but if it makes a difference to what we do, what we say, how motors are built, how roads are built, then well, no, because all that practical stuff that you spoke about is based on that we're on a plane. The measurement is that we're on a plane. You know, in an aircraft and in sailing, you know, they all assume a level Earth. That's the axiom that they start from. But for me, it's usually important in the aspect of the existential questions that I ask myself, like, who am I, why am I here, what's this all about? And if I start from a false foundation, i.e. I think I'm on a globe spinning about in a vacuum, it's really difficult to try and make sense of the world based on that faulty foundation. Does that make sense to you? If you start with a wrong answer, then you're always going to end up with a wrong answer. Exactly. So again, you know, we talk about measurement, scientific measurement, and for me, real science is about the natural sciences, as we spoke about, the real world and substances and stuff. So one of the first things I always point out, regardless of the planar principles that we use, there's a substance that's abundant on this earth known as water. Now it's my understanding that water will take the shape of any container, it will fill any void, the surface will always equilibrate, it will always be a horizontal plane regardless of the scale that I test and I can measure and I can show everybody. Now again, planar principles, the abundant substance known as water tells me beyond any shadow of doubt that I'm on an expansive plane. Can it be curving in any way, shape or form?
You look at the sea, it's flat. You look at a river, it's flat.
So that's your direct experience, that's right, isn't it? So as you see that there's a conflict with your direct experience,
and
scientific principles, and what you're being told and shown on a TV screen. Would that trigger you enough to have a wee further look into this?
Aye, definitely.
But avoid propaganda, because there is a lot of propaganda in regards to this topic, in regards to people making claims that it's an ice wall and it's floating in the vacuum of space. There's loads of nonsense in there.
So apart from the guy that you mentioned, how do we tell what's no propaganda, what is propaganda?
Well, be a direct realist, as you say, take things on your direct experience, scientific method. What can you actually demonstrate for yourself? What the claims that people are making, are they being quantified? Can they be repeated and peer reviewed over and over again? And there's a huge difference between real measurement and mathematical equations and postulations, because maths is a formal science. It's not a natural science, it's a language. So unless its axioms are rooted in something objectively true, like something in the real world, you know, it can wander into abstract. And for me, that's what's been passed over. You know, we've got, you know, like Einstein with his postulations of relativity and astrophysics, trying to explain the outer reaches of our Earth. But the real science on our Earth is telling me that it's an expansive level plane, and there is absolutely no way for me to deny that. So I say I used to believe implicitly that it was a ball. I'd no reason to reject it other than an honest investigation into, you know, what I'd been told, and I found that it was absolute nonsense. They only show me a cartoon image on the screen. There's no an actual photograph that exists. So it's been excellent talking to you, mate. I really appreciate your honesty. I mean, could you tell me any of your thoughts right now, or are you just
You've brought up a lot of good points that I wouldn't have thought of, because it's not something I've ever sat down and thought of. But when you talk about it, and you talk about planes, you talk about plums and stuff, you're right where it's not shown that it's not flat. We're always told that it's a ball, and that's what you're taught from primary one all the way through every course, every college. So why no question the non-scientific facts that they're trying to give?
See, I see the religious, the similarities between religious dogma and this kind of science that they've told us. And just as you say, you know, you've never witnessed that, but you've been told it, you've been shown it on your TV screen, and people just follow it blindly and believe it. And I think that's kind of religious, you know, it's taken on faith without any real practicality. So, appreciate your honesty, mate.
Thanks very much for talking to me.
It's been a real pleasure speaking to you.
Mate.
Excellent, man. Cheers. The channel's called Beyond the Imaginary Curve. And I've done this quite a few times. We're an open platform. We invite anybody who wants to ever come on and follow the discussion. We've been inviting lecturers and supposed scientists for over 3 years now, and we're getting nothing. All we're getting is trolls who are offering us rhetorical crap, you know. So the same old stuff that we've always heard, but much appreciated, buddy. It's been a real pleasure. Thank you, my man. Cheers. Hi mate, what's your name?
Ewan Watson.
Ewan Watson, how you doing? I'm Del. Ewan.
Oh, nice to meet you.
Pleasure to meet you, sir. What I'm asking people, sir, is can I ask you, you say you work here, did you study at all at any point?
Yes, I studied here just a couple of years ago.
Okay, well, can I ask you what you were studying?
3D modelling, 3D animation.
3D animation. Can I ask you then, maybe you would have heard of this, do you know who Alexander Euclid was?
No, exactly, no.
You ever heard of Euclid's elements?
I believe so, yes.
You know about Euclidean geometry?
No, unfortunately no.
Do you know the geometry that you were applying to your, did you say you were a computer programmer?
No, like a 3D artist kind of
thing. A 3D artist. So do you understand the basics of the model that you'd have been using? Was it planar? Was it?
Oh yeah, it was like planar modelling.
Planar modelling. Yep. So that's my point. You know, I'm really staggered that students have never heard of Alexander Euclid, who's considered the father of geometry. He wrote Euclid's Elements, run about 1600 years ago, but the elements were being applied long before that. The Euclid's Elements are the mathematical axioms that we use in the real world. So the practical world of construction, navigation, you know, 3D modelling and computers. Now that geometry that we're using is planar geometry. Do you understand what that means? You understand? It's not non-Euclidean, it's no spherical geometry, it's Euclidean planar geometry. That's the real world applications, right? The problem with that is that it's not concerned with curved surfaces. But yet we're led to believe that we're living on the exterior of a spherical Earth. Have you ever questioned that?
Well, wait, is this like a flat earth theory kind of thing?
No, I don't postulate any flat earth theory. I'm just a realist. I've questioned the globe. I used to believe in the globe. Now I've got serious questions about it, and we're trying to invoke discussion with, like, you know, university lecturers and bring it into academia, who so far are avoiding it like the plague. So what we're looking for is just to gather honest responses from people. You know, one of the questions I ask is, I'm going to ask you, you believe it's a globe?
Yes.
Could I then ask you your reasoning processes? Could you give me the reasons for why you believe so?
It's just mostly how gravity works.
How gravity works?
Yeah.
What's your definition of gravity?
Basically, like, you know how around a point. Sorry, it's really hard for me to explain.
Yeah.
But it's just kind of like a whole flat world. It's kind of like something they believed in, like, the olden times. Like, if the ship kind of sailed far enough, they just fall off the edge, or if there's a waterfall leading to nothing.
Yeah.
Or
do you think these ancient civilizations who showed us great architecture and great geometric skills really believed in stuff like that they could fall off the edge? Or do you think maybe that's propaganda that we've been fed through years so that we would ridicule such notions? Do you think that's a possibility?
not exactly, I don't think so.
No, but the problem is nobody has ever provided a scientific measurement or practical demonstration for any of the globe claims. The only place that people have ever witnessed it is on a TV screen. So, you know, on your experience, have you ever experienced the Earth as a globe?
Yeah, I believe when I was on a plane I've seen the horizon.
The horizon, the horizontal, straight line?
Not exactly a straight line, it was more a curvature.
You think it was curvature? Yeah, well, mainstream science would say that at that altitude it's too big for you to see the curvature. So the problem is sometimes we've got spheres for vision. So you've got to take that into consideration. Your eyes are curved, it's a curved surface.
Ah, you're talking about field of view, that kind of thing?
Yeah, you're also looking through curved windows. Okay? But a visible phenomena can't be quantified. You know, if I asked you to quantify your vision and show me that in a scientific measurement, you would have a real difficulty. It's like right now, if we looked down that street and I said, okay, can you tell me the size of that lamppost far away down there? I mean, if I do that, it looks as if it's, what, 4 inches tall? Perhaps. So I couldn't quantify just based on pure vision. I have to move three-dimensionally around an object, measure it and quantify it that way. So visible phenomena is no quantification of or scientific measurement of anything. But again, if I go back to the Euclid's principles that are applied in the real world, it's plane geometry. So there's a contradiction, would you not say? If Euclid's principles don't apply to curved surfaces, but we use them, what would that then tell you about the real world? Confusing?
Just ever so slightly, sorry.
No, sir, it's absolutely brilliant, because this is not about making anybody look silly. It's just an honest investigation to the fact that I find it bizarre that students have never heard of Alexander Euclid. They don't understand Euclidean principles and how they're applied in the real world. You know, I've got a real issue with that.
It's kind of like those things that we don't really get taught. These kind of things in high school, you know, like we don't get taught about taxes, how to live in the real world. Like
exactly.
That's important skills.
Yep. So would you say there's a problem with the education system then?
Probably, but in that regard, probably to a lesser extent.
Aye. Aye. So,
but anyway, sorry to cut this short, but
no, it's been a pleasure speaking to you, buddy, and I really appreciate your honesty. Thank you for speaking to me, man. Alright, thank you very much.